track there. Okay. So we are graphing quadratic functions. Okay. There's our function. Took a little bit of tape. Don't need much. Tape my coordinate plane down. So there's gonna be like, I guess maybe 6 steps that we're gonna go through here. Okay. And on the PDF that I posted for your homework, it's all laid out like, which one is gonna be the exact same thing that we do right now. So shouldn't be any big surprise. Hopefully it's not the big surprise. The first thing that we're gonna do for this is we're gonna find that vertex. So where's our vertex?
5, -4.
Jared's saying 5, -4. What did Jared remember?
That H is a liar.
Jared, you weren't supposed to answer that. That's weird. It's third person. Goofball. Right on, Kyle. Yeah, H is a liar. Cam, have you ever done quadratic stuff? Where you were from? You haven't just. You guys pick that up yet. Okay. Is this familiar at all to you? Okay. All right. So I'm going to go ahead and plot my vertex. Okay, we've got the information. Might as well just put it on the graph. And I always like to label my vertex with FV just because it is the most important point of the graph. We really want to just kind of highlight it there. Okay. Next thing we're going to do, we're going to write the equation of the axis of symmetry. And when we write an equation for an axis of symmetry, what should it always look like? When we answer this question, what's the answer look like? I'm asking what the answer is. I'm asking what the answer looks like. Right on, Jared. Jared's on the ball, Jay. X equals, right? And X equals, when we say something about X equals, what do we always see when we talk about X equals? What does the axis of symmetry look like? Like physically, what does it look like? The axis
it's a vertical. Oh, sorry.
No, you're good. Vertical.
It's a vertical line that goes down the middle through the vertex.
Yeah, it goes through the vertex, and yeah, just like Jared and Pat said there in the chat too, it needs to be dashed. So it's a dashed vertical line. All right, that's why it's X equals, because all those X coordinates are the same. So that's our rule for the line, is that X is equal to something. Well, of course, what is X equal to? And X is equal to 5, right? And those two things are always connected. Shouldn't be a mystery. If you know one of them, you know the other. Those things that go together. And then we do want you guys to label that on the graph when you do that. So X equals 5 there should be on that. That's especially important if your axis of symmetry happens to be the y-axis, because then when you go to draw it, it's not very easy for somebody else to see that when you draw it there. So it's especially important that you would label it, x equals 0 here if it was on the y-axis. But we just want you guys to always label that there. So and there's that equation of that line. Good. All right, so now we need some more points, right? So that's gonna be our next task. We're gonna find at least more points. I'm gonna ask you guys to do this like a table or a t-chart. I'll use a t-chart. Okay. So this really is like the biggest question mark usually for students with this, because like step A, find the vertex, that's pretty prescriptive. Here's how you find the vertex, right? Here's how you find the axis of symmetry. Now we have this thing, find more points, but we have to make a decision, right? We have to come up with the x values to use in this problem in order to get y values out, right? We have to find the inputs. We have to decide inputs so that we can then get the outputs to go with those. Okay? Well, because of the way these graphs move, the way they change, right? The numbers start to grow really fast, or the numbers start to get negative really fast, right? So from what we know about quadratics, something we talked about on Monday was that the domain can be anything, right? The x values can be anything. There's nothing stopping me from plugging any number I want into this problem. They can all give me answers. Okay. When we talk about domain, it's the inputs that work in the problem, the inputs that will give you answers. There are some problems that when you plug a certain x value in, it doesn't give you an answer, right? We kind of saw that on the homework question that Aiden was just asking us about. We got a problem that didn't have any answers. With this, we always get answers. No matter what I plug in for x, it'll spit out a y. The problem here is some of those y's won't be usable because they're going to be so big or so negative that we can't graph them. Okay, so we have to understand that we could choose anything, but we shouldn't just choose anything. We need to choose something smart. Okay, we know where the vertex is, and we know there should be points right around the vertex. So we need to pick x values that are right around the vertex. The further you get away from the vertex in that x direction, the higher or bigger, either positive or negative, those values are going to get, the less likely you're going to be able to actually graph them. So you need to stick in this region right in here to pick values that are actually going to be usable. And they all will give you answers, but all of those answers won't be usable. Okay. So you always pick numbers either to the left or to the right of the vertex. And I would say, within 2 to 3 spaces of the vertex. Okay. What we're going to use, essentially we're going to do is we're going to find a point, like maybe there's a point right here. We're going to use that axis of symmetry to take that and reflect it over. So that 1 point that I found will then become 2 points. And then we're going to go over here and say, well, maybe there's another point right here. And I'm going to plot that point, and then I'm going to reflect it over. So now I found 2 points over here. So now I have 1, 2, 3 points, but I'm going to take those 2 points and reflect them, which is going to give me 4 or 5 points. Okay. So we're going to do math to get 2 more points. They'll reflect to give us a total of 4 more points. We'll have at least 5 points when we graph it. Okay, at least 5 points in order to graph this. Okay, I'm going to pick x values that are close to the x value we know. Right, it's right there. Okay, it's right there. Only on one side. I'm either going to go to the right or to the left. I'm not going to do both because then the mirror becomes useless. It's my general habit to go to the right. It's just my habit. Okay, so if I think about a number that's to the right of 5, like 6 and 7. The numbers I'm going to plug in. I could have also plugged in 4 or 3. That would be fine as well. I just like to go to the right. Okay, so we go to our function. 2 times 6 minus 5 squared minus 4. When you do that math, most of the time it's not that difficult to do in your head. Okay, 6 minus 5 is 1. 1 squared is 1. 2 times 1 is 2. 2 minus 4 is -2. So that gives me the point 6, -2. Now that I have that point, I'm going to go over here and plot it. And since I'm here, I'm going to go ahead and reflect it. So notice I'm 1 unit away on the right side. I need to go 1 unit away on the left side and plot that point. Okay. So we find 1 point and then we reflect it across. Now I need to go find another point. So I'm going to plug in 7. Do the math. 7 minus 5 is 2. 2 squared is 4. 4 times 2 is 8. 8 minus 4 is 4. So I get the point 7, 4. I go to where 7, 4 is. That's 2 units away on the right. So I'll go 2 units on the left. And there's another point. Said I wanted you guys to do at least 5 points. We tried to do another point, right? I did 6, I did 7. I could try to do 8, see what happens. Having more information is always better. Minus 5 is 3. 3 squared is 9. 2 times 9 is 18. 18 minus 4 is 14. We see that that point is actually not graphable in the graph that we have. So that quickly, right? That quickly the numbers grew that it's not graphable anymore as far as what we have available to us. Okay. So that's why it's so important that you stay close to the vertex. Even just getting 3 units away from the vertex, the numbers are already too big for us. Okay. So imagine if you tried to plug in like -4 or something like that, you're going to get this huge number. Okay. The absolute easiest thing for a student, you guys seem like you're doing a pretty good job of it, is the understanding that, that H is a liar, right? Because if I said H was -5, I started trying to plug in numbers that were near -5, right? So like I say, oh, I'm going to plug in a number next to -5, and so we plug in -4. Imagine plugging -4 into this. -4 minus 5 is -9. -9 squared is 81. 81 times 2 is 162. 162 minus 4 is 158. Okay. Because I got the sign wrong here, I tried plugging in a number that was way too far away from where it should have been, and then I get this giant number, 158. If you're getting giant numbers, guys, there's a really good chance that you forgot to switch the sign on the vertex. Okay. But it seems like for the most part, you guys are doing a really good job with understanding that. From the, for those of you guys that turn your homework in, I see. Seems like you're doing really well with that. Yeah, but it's a pretty good chance if you're getting giant numbers, it's probably because you missed a sign somewhere. So that'd be the first thing I would check if I were you guys. All right, so D, right? We're going to draw the curve. Okay, draw the graph. Oh, so any questions about like A, B, or C yet? Like, meant to write down why I picked the numbers I picked. Let me do that. Okay, so pick 2 or 3 numbers to the left or right of the vertex. Okay, and only do one side, right? Just to the right or just to the left. Let the mirror take care of the other side of it for you. Okay. Anything so far feeling like you're not sure where it's coming from? Anybody? Anybody? All right. So we're going to draw a graph. Remember, the graph is supposed to be a parabola. It's supposed to be U-shaped. It's not a V like with the absolute values, right? So it's supposed to look like a curve. It's going to be a pretty sharp curve, so it's going to look kind of V, but it should look something like this. All right, connect that vertex out. Of course, the arrows on the ends of the graph. But it should be doing those things we've been talking about, right? We spend so much time talking about these transformations, right? Hey, there's our stretch. What's the stretch do? Makes it skinny, right? Makes it narrow. So am I seeing that? Does that look like a skinny parabola? Oh yeah, kind of. Right? Did it shift to the right? Did it shift down? Right? Are we seeing those things we've talked about so much? Does our graph make sense? Okay. So I want you guys going back and looking when you draw the graph, like, does this look the way it's supposed to look? Because if you're drawing something all wiggly woggly, like, then you have no idea what's going on, right? Like, without like you saying, hey, here's what I got, it doesn't make sense. Like, this is, I know this is not what this is supposed to look like. Okay? And I absolutely love if you guys would come to me and say that. Okay, here's what I did. I know it's not right, but I can't figure out what's wrong. Rather than, here's what I did, and then it turns out to be a whole pile of poop. Like, I'm not happy about that. Okay, I want you guys to be thinking, like, does this make sense? Does this look the way it should be? Right? Like, critical thinking stuff. And it's not about math, it's about that you're thinking. Next thing, we're going to find the min or max. All right, does this function have a minimum or a maximum? All right. Let's look at that. It does not have a top because it goes up forever, but it does have a bottom. All right, so that means it has a minimum. All right, and what's that minimum? All right, we're talking about max. We're talking about the y value there. So what is that lowest point? And that's at -4. Again, that shouldn't be a surprise. Those two numbers should always be the same. It's just, is it the highest or is it the lowest point that's going to change? But those two numbers should always be the same. Okay. And the last thing, our long list here, we're going to talk about the domain and the range. Now, and I already mentioned earlier in this problem, like, about the domain, and we talked about the domain stuff on Monday. All right, that look at that leftist side of the graph, and we see that it's an arrow pointing to the left, and we look at the rightist side of that graph, and we see that it's an arrow pointing to the right. All right, and then there's all those points in between them. All right, and we talked about on Monday how the domain for a quadratic function is always going to be all real numbers. Yeah, there's rough infinity. Sorry. Okay. Again, what that means is that the domain is our set of inputs. That means we can plug in every number. And I already said, we said that earlier, right? I can plug in any number I want into this. Okay. The math will always work. We'll always get an answer. Okay. Well, the other side is, what are those answers? What are those outputs? What's the range? Okay. So we go from left to right here. We go from low to high on the range. So as I look at my graph, the lowest thing I have, lowest value I have is -4. Or right there at -4, it's hitting it, so it's going to get a bracket. And then keep looking for the highest point on the graph, where there is no highest point because it goes up forever. And then it goes to infinity. Okay. What numbers can I plug in? I can plug in every single number that there is. Okay. They will all give me answers. What answers will I get? Well, you're only going to get answers that are -4 or bigger. We would never get -5 as an answer. We would never get -10 as an answer. Okay. The lowest answer we can get is -4, and then all the other answers will be bigger. Okay. So that's what domain and range are about. Okay. There's that visual side of it, the left to rightness, the low to highness, but it's also, what does it actually represent? What can I plug in? What am I going to get it out? Okay. We're going to do another one. Was there anything like right now that you guys feel like you need to go back over, or anything you want me to like talk more about next time we do it? Because ideally next time I'm going to have you guys telling me the answers. Anything right now you guys want to go back over? Kyle's got it. Okay. Let's do another one. Here's our function. I'm not gonna write down the steps each time, like what I'm doing. I'll write A, B, C, D, and but it's gonna be the same steps that we did last time. Okay. Let's find that vertex. Camel, where's our vertex? Camel, are you there? Okay. Kenzie, what about you? Where's our vertex? Oh, Kenzie's not here. My bad. I saw her earlier. Mason Hare, where's our vertex?
It's at our birth.
Yep.
Okay. Would would it be 3 or 1?
3-1. Third time?
Yeah.
Okay. Tion, can you give him a little hint? Without telling him the answer. Give him a little hint, Tion. Well, that was a big hint. What's going wrong here, Mason?
Oh.
What are you forgetting to do?
Oh, because like the -2. So would it be -3, 1? Or am I wrong there? Hold on.
Your answer's right, but your reasoning is wrong. Kyla's giving you a hint there. What's Kyla telling you?
H is a liar.
So what's H?
Oh wait, hold on. Oh.
What's going on here?
Okay, so if H is what was like the FX is
You mean what's the problem?
then
Sorry, my program's being weird here. The screen die on your end, you guys?
Yes.
Okay.
yeah.
Yeah. My notebook program crashed. One that lets me use the camera. It's trying to get it back up. So Mason, it said x plus 3 inside the parentheses. Okay, but H is a liar. So when it says plus 3, we need to remember it's actually -3.
These it would be right.
Inside of the function. Right? When we were doing the absolute value stuff, it was the numbers that was inside the absolute value. Right here, it's inside the thing that's inside the square with the x. Okay, it's that thing in there that's lying to us, right? Because it's supposed to be x minus h. When we say x minus -3, that's going to act like a positive 3. And so, hold on a second. Let me get this going here. You guys again. Okay, let's share this folder. All right, we're back, guys. Is that it? Let's see here. I feel like that's smaller than it was. Oh, why does it keep freezing? Good Lord. It's really frustrating. All right. Dang it. That was wonky. Been fine all day. How many of you guys are getting this? What's going on over there? I can barely see the. Trying to fix this now. Why is it doing this? It's just been super laggy. Yeah, you guys do have the ability to change your view when I am sharing my screen. I guess I don't know if anybody ever went over that with you guys. Oh my God. It's been fine all day. Okay, there's that. That seems like it's working. What can you guys see right now?
We can
You
see
see it? You can see it?
At least I can.
Okay. All right. -3, 1 now? Everybody else good?
Yes.
All right. Okay. Whew. Let's go ahead and plot that point. -3, 1. Boom. Vertex. Oh, okay. It's laggy. Okay. That's super fun. Okay, so next thing, where's our axis of symmetry?
It would be x equals -3.
Yeah, right, good. X equals -3, and you know, is that vertical line, that equation of that vertical line? And again, we just ask you guys to label that. And then from there, we need to find points. All right, so set up your little T-chart or whatever you're doing to do that. So what values should we pick for those x's? What would be good numbers to pick for x? -2 and 1. Why those, Kyla? Why -2 and 1? because they're closest to the vertex. So what else could we have used besides -2 and 1? What would be other like good points to use? Yeah, right, kind of -4 or -5, right? It doesn't matter which, if it's that left side of -3, so -4, -5, or it's the right side of -3, -2 and -1, right? But they're both right next to -3. It's just one side or the other. So to your question, Jared, we probably shouldn't. Most times those would be too far away, like how we saw how big the numbers here got so rapidly. So that's kind of too far away. So we need to stay pretty close most of the time. So, all right, so let's plug in -2, let's plug in -1, or if you want to plug in -4 or -5, go for it. I'm not going to do this one by hand or mentally. Not that I couldn't, but just I want to show you guys something. So using calculator, and that very first email I sent you guys this year, I recommended that you get a graphing calculator app for your phone. The one I use on my iPhone is called Free Graphing Calculator. Quite amazing. So -2/3 times -2 plus 3. So on this one, it's this little caret or square. Squared plus 1. Okay. Type that in. I get 0.3 repeating. Okay. A couple things. 0.3 repeating is 1/3 as a fraction, right? That's just 1/3. You guys should know that. And other thing, we can't graph like 0.33333. Like we can't, even if like going to like the 100th or 1000th, we don't have the ability as people to graph that accurately. Okay, so all I'm asking you guys to do, if you get a decimal like that, is just round to the nearest 10th. So that would just be 0.3 or 0.3. Okay. So that means we're going to plot the point -2, comma 0.3. Okay. So as I go to do that, so -2's here. So 0.3 should just be right above the x-axis, right? About where 1/3 would be, right? It should be kind of below 1/2, but higher than 0. And then I want to go to the other side, right? I'm 1 unit away here, so I'm going to go 1 unit on the other side and reflect that point. Okay. I'm going to do -1. So what I like about this app is that the equation I want to do is essentially the same as this one. So all I have to do is tap it, it brings it up for me, and I can go and edit it. And change that to a -1. Hit enter now. So there's 1.6 repeating. Okay. 0.6 repeating is 2/3. So that's -1 and 2/3. But again, I'm just going to round that to the 10th. So -1.7. And how do I graph that point, right? Here's -1. Well, here's -1 and the y. Here's -2 and the y, right? And -1.7 is between those two numbers. It should be closer to the -2 than the -1. It should basically be right above -2, right? And that's 2 units away on the right. So I'm going to go 2 units away on the left, but keep that same level. And so notice how the point is being mirrored. So generally with like a compression problem, right? This problem is being compressed. That 2/3 is compressing the graph, right? It's making it wider, it's making it shorter. Those graphs grow quite a bit slower. Like look how slow these points are moving in comparison to how fast these points are moving vertically. So this lets me have more time to put in more points. Again, at a minimum, I want you guys to have 5 points. So we've met the minimum. I'm gonna go ahead and do another point just to make the graph better, okay? But if you want to stop here, you can. You've hit the minimum value, okay? Or the requirement. I'm gonna go ahead and do another one just so we can see what it looks like. We tried it last time, we saw that it didn't work, right? Again, I'm just gonna tap this. Need to change that to 0. Oops, that's not 0. And it tells me when I plug in 0, I get -5. So get a nice easy point to graph here. 0, -5. which is right here. That's 3 units on the right. So I'm going to go 3 units on the left. So I should put a point right there. And I actually might be able to do a fourth one, but I'm not going to. So I'm going to draw a curve through those 3 points on the right. I'm going to draw a curve through those 3 points on the left. So our graph should look something like that. That's a pretty looking parabola, if I do say so myself. So a couple things here at the end is after we draw that picture, a couple things I don't want you guys doing. When you're finishing that curve, I don't want you guys to draw it straight down. Right? It doesn't keep going straight down or straight up, right? It should keep expanding out to the side, right? It should keep going on a smooth curve out. Okay, so you don't draw straight down or straight up. And kind of the other thing you don't do is you don't bell out. So it shouldn't like all of a sudden make like this big hook in it. Right? Either way, like if it's belling in or belling out, it shouldn't do that. Okay? Or it should not go straight down. It needs to keep that curve. Okay? It should keep expanding to the left. It should keep expanding to the right, but smoothly. It shouldn't make a turn all of a sudden. This is where the graph turns. Okay? Most of this is pretty smooth, pretty almost straight. Okay? It's at an angle, but it's straight. Okay? So it should never like bell out like that. The only reason I mention that is because I've seen so many students do that. It's just not how it works. So, okay. Anything here so far before we do the last two pieces? Okay. What do we got, min or max on this one? Minimum? What's our minimum value, Jarrett? 1? -5 is smaller than 1. -1.7 is smaller than 1. What do you mean? Yeah. Yeah, max. All right, that graph that's the highest point of the graph, right? There is no minimum because those go forever down. Okay. All right, last thing. Domain, that should be a gimme. What's our domain every time for these?
Negative infinity, positive infinity.
Negative infinity, positive, right, Mason? Oh, Lord. Because it goes left forever, it goes to the right forever. And then our range, you got to stop and think a little bit more about our range. When we go to look for the range, where's the first place on the graph we look? Where do we start looking when we talk about the range?
The vertex.
No, not the vertex. There you go, Kylo. Bottom up. All right, so we start on the bottom of the graph. We go to the top of the graph. Remember what this is? This is left to right. We look at the left side first. We move to the right side. And what I like to say for the range is it's low to high. And I like that because it's alliterative. Left to right, low to high. Left to right, low to high. We start on the lowest part, which in this case is negative infinity. Then what's the highest part, which is 1. Go from negative infinity to 1. That max gets that bracket. Okay. Again, we can plug in any number. We can plug in any number we want, but we will only get out numbers that are 1 or less. We would never get an answer of 5. We would never get an answer of 12. Those values are not possible for this to get out. Okay. You only get numbers that are 1 or less. All right.